Hello guys, good afternoon. So we are back on another tutorial video for the series. So today, like I said, we are going to be working on the calculation part of the questions at the back of the textbook. So without wasting much of our time, let's just get into it. So my notes are ready, and myself, I don't ready. So you, are you ready? Let's just get into it. So okay, before we move further, this is our YouTube channel, so please you can come here, subscribe, hit the subscribe button, then you turn on the notification bell. So every time we post a video, I post a video here, you get notification. So you can also click on this button here to follow me on Twitter and all of that. So for this course, I created a playlist for us. So this is the full playlist here. Okay, I think this is the first video. So this is the first video. Um, I did the introduction to majority of these videos here are on VB. So this is the part one of what I'm about to do now. So practice questions for FS 113 exams. The first one 20 questions at the back of the textbook. So this one is the second set of questions. There are 350 numbers, so I covered them, but I skipped all the ones that had to do with calculation. So I'll be taking all those ones now. So let me come back here. Now I need to. Well, I don't know if I should call it a warning. Well, or tabele, anything you want to call it. Please don't go to your first 113 exam hall without a calculator. Please and please. Some of those questions there with your calculator, it won't take you up to 20 seconds to solve. But if you want to do it by hand, you might make mistakes along the way, and it might actually take you time to actually complete it by hand. But knowing how to do it by hand is a plus already, because there are some questions you might see that your calculator will not be able to solve outrightly. So all the questions at the back, I'm covering everything in this video. I'm covering everything in this video. So you won't have problems at all with FSC 113. I'll also cover the ones that have to do with code and all that. So let's just get into it. Let's get into it. So please, like I'll advise us that before we watch this particular video, try to watch these two first, so you know exactly how I came about this particular video. So let's continue. The first question I'm going to be solving, the first set, number 19. The first set of questions, number 19. Okay, this particular question over here. So you can see the decimal equivalent of 0.1011. It should be base 2. It should be base 2, but as you can see here, the it is giving us 1011 then 2. It shouldn't be like that. It should be base 2. So let's go ahead to solve it with the base 2. So that will be 0.1011 base 2. Okay, so um 0.1011 base 2. So normally what you want to do to convert this particular binary to a decimal, all you have to do, convert this binary to decimal, all you have to do is to do something like you put 0 at top here, you have minus 1 here, minus 1, minus 2, minus 3, minus 4. So just numbering the, I'm trying to write my phone. Okay, just numbering everything. Then when you are done, I'll still show us how to do it with the calculator. So basically what you're going to be doing is 0 times 2 raised to the power 0. So normally this will be giving you 0 plus 1 times 2 raised to the power minus 1. So plus 0 times 2 raised to the power minus 2. So plus, this is just secondary school work safe. So plus 1 times 2 raised to power 7 is to minus 3 plus 1 times 2 raised to power minus 4. So cover this and cover this as well. So let me make a bit of room. So if you solve this down, what you're going to be getting is 0 plus 1 over 2 plus 0 plus 1 over 8 plus 1 over 16. So that's what you're going to be getting if you, because 0, let me change my pen here. So let me try to use this one over here. So this thing that I have over here now is going to be giving me 0. So this one that I have over here now is going to be giving me 1 times 1 over 2. That is 1 over 2. So what I have over here is going to be giving me 0 basically. So that's why I have 0 here. So this is going to be 1 over 8 times 1. So that's why I have 1 over 8 here. So 1 times 1 over 16. That's why I have 1 over 16 over here. So let me go back to my black. So the next thing you're going to be having is 0 plus half is going to be giving you 0.5 plus, let me just do away with the zeros. So plus 0.125 plus 0.0625. So normally when you're done solving this, it should be giving you, if you should calculate all this together, it should be giving you 0.6875. And if you go to your question, this is the E option, 0.6825. So you can see how simple it is. It's not complicated at all. God, my E is quite bad. So you can see the E option, 0.6875. Now that is doing it by hand. But like I said, please and please, well, you've never written the exam before, just make sure that you go there with a calculator, please. But one thing is that we understand the fact that this is exam period when everybody's calculator will start growing wings very soon. It start growing wings very soon. So I can't overemphasize this. Please make sure you go to the exam hall with a calculator. We know that some people can't afford it, so they have to solve by hand. Calculators are quite expensive now, but please and please, like I said, if you can afford to get a calculator, go to the exam with a calculator. It will be useful to you for other courses as well. So if you can borrow from a roommate, that is fine and good. So let's continue. I want to show you how to use the calculator to solve this question that I solved just now. So come back here. Now number 19, come for the calculator. So this is the FX99 1ES Plus emulator for PC. So normally when you on your calculator, the natural display calculator, this is how the calculator is going to be. So I want to use it to solve this one. Now you can see that what we are trying to do here, we are looking for the decimal equivalent of this one now. Decimal equivalent of this. So one thing is that for this particular question, your calculator will not be able to solve this, yes, because the natural display calculator, the let me show us. Normally, when you want to do anything in binary, you click on mode, then you click on. You can see 4 is for base n. You click on 4. The same way this will work on my system, the same way it will work with the one in your hand. So you can see this is the decimal. It's in decimal now. I want to change it to binary. So this binary that the natural display calculator works with is in integer mode alone. So you can't work with decimals using the natural display calculator. That is why I said it is good for you to always know how to do it by hand. So if your calculator is limited or you don't know how to solve with your calculator, you solve by hand. So for this particular one, normally if it were 45, I want to no, 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 no. Delete. So let me say 1101. If I want to convert this, for example, to a decimal, I'll just say equals to. So you can see what I have over here. Then I will click on DEC. This is the decimal equivalent of this. So now if I want to type in this now, it will not allow me to type this because it works only in integer mode. So if I come to binary and I want to say 0 point, you can see the point is not working. I don't know if it will work in the one in your hand. But for this particular question, your calculator won't be able to solve it. So you have to do it by hand like I did. So it's not a difficult question actually. So that is that about that. So for we go ahead to number 21. I don't want this. I want to keep this video as short as I can. So I don't want it to be too long. So it will be. I don't want to say boring. So number 21. Um, number 21. So when converted respectively to binary, octal, and hexadecimal, the decimal number 65 is what? So let us solve by hand first. Then I'll solve a few questions by hand. Then the remaining ones that we're going to be doing, I'll solve them with the calculator. So knowing how to solve by hand is very important too. So I want to convert 65. So the 65 is going to be in base 10, and no, this is already in base 10. So I'm to convert to binary. So now let's convert it to binary. If you want to convert 65 to binary, you remember this. So this will be 265. So 2 in 65, I'm going to be having 32 remainder 1. So I have 2 here. So let me just to make it neater. So 2 in 32, I have 16 remainder 1. 2 in 16, I have no remainder 0 rather. So 2 in 16, I have 8 remainder 0. 2 in 8, I have 4 remainder 0. Let me demarcate them to make it neater. So 2 in 4 again, I have 2 remainder 0. Then 2 in 2, I have 1 remainder 0. 2 in 1, I have 0 remainder 1. So very good. So now if I should bring all these things together, normally this is how the answer is going to be. So from here down up. So I'm going to be having 1 0 0 0 0. How many zeros? 1 2 3 4 5. 1 2 3 4 0 1. Then base 2. So this is the binary equivalent of 65. Now working on the octal equivalent. Get out. Okay, so to work on the octal equivalent, so I have 8. Then I have 65. So 8 and 65, I think that should be 8 times 8, 8. Remainder 1. 8 in 8 will be 1, remainder 0. 8 in 1 is 0, remainder 1. So don't forget, so this will be 101 base 8. So this is the octal. So this will be the octal. So for the hexadecimal, so for the hexadecimal now, I'm having 1665. So normally 16 in 65 is going to be giving me 4 remainder 1. So 4 remainder 1, then 16 in 4 will be giving me 0 remainder 4. So don't forget the answer will be 41 in hexadecimal. Now bringing all my answers together, so I have I don't know. Okay, so I have this, I have this, and I have this 41. Now let's go and check which of them serves the purpose. When I tried solving it, I couldn't get any one of them that was exactly like this. So I have this D over here. I have this D over here, but I'm having 5 zeros, and I'm having one, but the hexadecimal is correct, but the octal is not correct. In my octal, I'm having 101 base 8, but this is 81 over here. So for this number 21, there is no answer. There's some other questions too like that. There are no answers. But trust me, in your exam, every question has an answer. In your exam, every question has an answer. So please look very well, please. So we move on to the next calculation question. So I'll try to cover everything in this video. The next one that we're going to be working on is number 36. Number 36. Yes, number 36. So, okay, let me try to use the calculator to do this number 21. So, you see how you'll be able to do it to save your time. So, the question itself is number 65. The decimal number is 65. So, on so it's already in mode n, please. So the mode, you click on mode, you look for base n 4, just in case your calculator is not in that particular mode. So the number is in base 10, so 65. You click on 65, you say equals to, so you have your 65 here. Now we want to convert to binary first. You see this bin over here, you can see what I have. This binary 1000000, then 1, you can see. So this one is almost correct now. So for the octal, if I just click, since it's the 65 already, I can just say OCT. You can see we got 101 in what we solved, but this one is 81. So, and there are no other 101s here, so that is wrong. Then hexadecimal, just click on this one over here. You can see the hexadecimal is 41, exactly what we got. So let's just scroll to number 36 and get on with it. So the result of this plus this one is quite simple. This one is quite simple. So if you want to solve it using the calculator, you put it in binary mode. You put your calculator in binary mode. This will be 110101 plus 10001. If you click on equals to, you can see I have 1000. I have 1110. So this is 1110. So A is the answer here. This is me solving with the calculator now. So the calculator, trust me, you can't. I can't stress this enough. You need to go to your exam hall with your calculator, please. You need to. You need to. So let me now solve by hand. So you see that it's the same thing solving by hand. So don't forget, we are trying to say. Let me. Okay. So 110101 110101 plus 10001. Okay. So now if you want to do the primary school style, you remember what we did in primary school, all of us. So you will say 11001. So 10001. So you put your plus sign here and you start solving. So 1 plus 1 will give you 10 basically. So because we are adding in binary, so this will be 0. So I'll carry the 1 and I'll bring the 1 to this second row over here. So 1 plus 0 is giving me 1. So 1 plus 0 again is giving me 1. So this one will be 1. So 1 plus 0 is what? 1. 0 plus 0 is 0. 1 plus 1 is 10. So I'll write 0, carry 1. So I'll bring the 1 somewhere here. So 1 plus 1 again is 0. So I'll carry 1. There's no other thing to add. So I'll just append my 1. So you can see it is still 1110. So this is you solving by hand, and this is your option A. So that is that about that. So number 36 is completed. So now number 38. Number 38. Okay, this is number 38. What is the ones complement of this? Now this one is a very simple one. I won't want us to waste much of our time on it. Now for you to find the ones complement of a number, all you have to do is to change all the ones to zeros and all the zeros to once, and you are done with it. So let me show us. Let me show us. So to find the ones complement of 100101101. I hope I'm correct. 100101101. Yes. So this is going to be this one over here now. Let me change my pen. So this one over here now will become 0. This one over here will become 1. This one over here will become 1. This one over here will be 0. This will be 1. This will be another 0. This one is going to be 0. This is going to be 1, and this is going to be 0. This is your final answer over here. So this is B, the option B. You can see how simple this thing is. This is the only A I had in year 1. I used to tell my students. I believe that at least if you don't have any other one, at least get this one. Get this one. So let's continue. The next one we are going to be solving is number 85. Number 85. Number 85. Where art thou? Okay, this is it. So number 85. The last video I recorded, I wasn't really sure about this particular question, but now I will tell you, just choose I equals to 1 is assigned to 1, period. Just choose it and go your way. So for number 86, this one of these two is correct, but it's a typographical error. Normally it should be x raised to the power of 3. So x raised to the power of 3 as per x raised to the power of 3. So this is what is supposed to be the right answer. But since we are at a disadvantage because we don't know what they were supposed to type, so and we don't know the operator here if it's supposed to be the equality sign. So just go with that. Um, number 95. Number 95. The variable name as data type is the answer of this one. So for number 96, let me do a bit of explanation here. Now for number 96, the options that you have, let me write all the options out so we'll start ticking all of them one after the other. Now for option A, we have um, A equals to 2 multiplied by one funny sign. No, 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 no. So I don't know. Then so that is A. Then B is A. Then we now have this colon here. I don't know what the colon is doing there. So we have 2 multiplied by the funny sign again, multiplied by R. So the C, A, then we have some colon equals to 2 multiplied by 3.14 multiplied by R. Then we have D, which happens to be A equals to 2 multiplied by 314, it should be points here, multiplied by R. Okay, then E, it says none of the above. Okay, so this thing is not giving me red. Putting this up. I don't know why. Why should it be so difficult to get a red? Okay. So let's take a good look at all these things that we have here now. Let me zoom out a bit. Okay. So for this first one over here, for this first one over here, I don't know what this character is looking for here. I've never seen it before. It looks like standard deviation or variance or something, but I don't know if VB will permit you to use this in the code. I don't know the reason why they are using this one here. So if not for this one, it could have been correct, but obviously it's not. So that is what disqualifies this one. Now for the second one, this colon over here, this is not how you do assignment in VB. Assignment is just whatever you have on the left equals to whatever you have on the right. So in this case, this is what disqualifies this one. So for the third one, again, this colon over here, this colon over here, so it's what disqualifies this one. But for that last one, the last one is correct because basically you have whatever you are assigning it to, which is the variable, and you have the expression here. So this is what I would choose. This is what I would choose. So let's go back to our, okay. So number 96 is gone. Number 97. Okay. So for number 97, now I did some digging here, sub, main, dim num, whatsoever. So the first error that you're going to be having here is this number 5. You can see I have full stop right line, and that full stop right line, there is no closing. You open the bracket here and you didn't close it over here. So number 5 is already a contraband. Now, this is saying a student gave the solution below as the program to add integers from 1 to 19. So basically, what we want to do is to say 1 plus 2 plus 3 plus 4 up to 19. There is no reason for us to read line. Read line basically is reading input from the user. Understand? And normally it should be console or write line and console or read line, not just write line and read line. So 5 and 6 are wrong, but okay, you can see 5 and 6 are wrong. 5 and 6 are wrong. Now, for this number 9 now, it should be console or write line. But let me see if I should take away this console over here now. I want to, and I just say write line. So I don't know if it will work well with VB, but it is worth giving a trial. I am a boy. So around this, you can see I'm having errors here. I'm having errors here. So normally it should be console dot write line. So run this. You can see I am a boy. So just saying only right line is also wrong. So normally your 5, the line itself is have some syntax errors. Your number 6 is not needed in this program, so I will still classify it as incorrect line. It is not needed here. Also, the number 9, it should be console or right line and not just right line alone. Apart from that, every other thing works just fine. Every other thing works just fine. So it should be 4, 5, and 9. But I don't know. No, 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 no. It should be number 5 and 6. Okay, yes, 5 and 6 and line 9. So C and D, in my own opinion, are correct. But if you have any contrary, if you have any other contrary opinion, please, I would like to learn from you too. I would like to learn from you too. No man is an island. You can just drop it in the comment section and we'll go over it together. So that is all for that particular question, 97. The next one is 101. Next one is 101. Okay, so okay, which of the following is a valid variable name? Interest rate is the valid variable name because dim is a keyword. You cannot use this. Select is a keyword and percent index. You can't. Now, going to 101, a program to add the positive numbers from 1 to 100 is given below. So submain whatever dim I sum as integer, sum equals to 0. Now since we want to add the positive numbers between 1 to 100, so they are starting a loop here for I equals to 1 to 100. Now it should be sum equals to sum plus I. What we are doing basically is that we are increasing the value of sum by I. That is what we are doing here. We are increasing the value of sum by I. So anything that is in sum before, let me do a bit of illustration here. Let me do a bit of illustration here. So if you say something is let me say sum equals to sum plus I. Now, if sum, for example, equals to maybe 23 and I equals to 2, basically what you are saying is that sum equals to the old value of sum, which is 23, plus I, which is 2. So the new value of sum will be equals to what? 25. That is what you are doing basically. That's what you are doing. So sum equals to sum plus 1 is basically increasing the value of sum by whatever is on the other side. So the answer for this one now will be sum plus I. So I is the answer. I is the answer for this one. Just put I inside here and the program is fine. So and another thing I noticed is that in this place as well they use right line alone. So for here I think we are going to be ignoring the right line and use only number five and six. So 5 and 6 will be the answer for this one. See, just 5 and 6. So for 102, okay, it's almost similar to for 102. It is saying a program to multiply the positive integers from 1 to 12 is given below. So what you want to do normally is to scan through the program. They are saying what is the missing arithmetic operator. The question is not complete. That could be, but what I presume is that if you look at this line 5, it is saying PDT equals to PDT. Normally it should be times I. It should be PDT equals to PDT times I, so that you know that okay, this you cannot just say PDT equals to PDT. If PDT is PDT for 12 times, let's do the illustration. Let's do the illustration. So let me say I'm doing something like let me say PDT equals to, so PDT equals to maybe 10 and I equals to maybe let me say 2. Now if you say PDT equals to PDT, what you are doing is basically that you are reassigning 10 to PDT. This 10 now you are reassigning it to PDT because the value of PDT is 10. So you're basically just reassigning 10 to PDT. But if you say PDT equals to PDT multiplying I, this is going to be giving you 10 multiplied by 2, and it's everything is going to be what? It's going to be 20. So comparing it with what you have here, PDT should not be equals to PDT. It should be PDT equals to PDT multiplied by um, I, which is the count variable here. You can call it count variable, index variable, or control variable. This I over here, that's what you call it. So the answer should be B, in my opinion. So it should be B. Although there are a lot of typographical errors here, so you just have to assume rather. So the next one is number 105. So the following for next loop makes how many passes? It makes how many passes? Now let me let me do a bit of illustration here to explain. In VB, if you want to write a loop, you say for you can say maybe x equals to maybe 1 to 20. Then you now write the body of your loop. After writing the body of your loop, you now say next x. This is how the normal way to write a loop in Visual Basic. Let me increase. Okay. So now this is how you write a loop in Visual Basic. Now, um, normally another way you can write a loop is to say for x equals to 1 to 20, step 2. This 2 over here, it can be anything at all. It can be anything at all. So let me just make room for the body of the loop. Then you next x, don't forget. Now let me zoom all these things out. You can see two ways by which you can write a loop. This one over here now, basically, it will start counting the loop from 1, 2, 3, 4, everything up to 20. So you are not giving it any step over. You can see that the step of this one is 2. If you don't include any step here, then VB will take it that automatically that okay, the step is going to be 1. So it will be counting from 1, 2, 3, 4, 5 till it gets to 20. And it's also going to count for 20. So for the first iteration that you have over here, the body of the loop is going to be taking x to be 1. The second one, x is going to be 2. The third one, x is going to be 3, like, and so on and so forth. So that is that about that. About the first one. But the second one, if you take a good look, I have x is running from 1 to 20, but the step is not 1, the step is 2. So guess what? It's going to be running as per 1, comma. Now the step is supposed to take 2 steps. So the next one is going to be 3. The next one is going to be 5. The next one is going to be 19. You understand? But after 19 now, normally it wants to take another step, 21. It is not going to be executing for 21 because 21 is already greater than 20. So it's not going to be executing for 21. So in this particular case now, this one is going to be making 20 passes because it's counting from 1 to 20 basically. But this one over here now is going to be making I think it should be making 10 passes, but let's just check. It's going to be doing for 1, it's going to be doing for 3, 5, 7, 9, 11, 13, 15, 17, 19. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are 10 passes it's going to be making. Because the step of this one basically is 2. Is 2. So now let's go back to answer the question that we have. Let's go back to answer the question we have. So, okay, this is the question over here. Sum equals to 0 for I equals to 1 to 20. So it's going to be making 20 passes because it is basically counting from 1 to 20. So that's why 20 will be the answer for number 105. Okay, for number 105. So for this number 104, let's treat number 104 as well. So for number 104, I think this is assembly language code. This is assembly language code, and the way assembly language is written is basically like English language. You just have to use your intuition. It is not written that direct, but you just have to use your head to juggle everything together. You get. So now, as you can see, this first one that I have over here now is telling me 20. Um, this might be line 20, line 30, line 40 or something. Just ignore the lines basically. So it's saying read A, B, C, D, E, F. Basically, this one should be telling you that they are reading user input or they are reading these values into that particular program. And as you can see, they are reading how many values? 6 values. 1, 2, 3, 4, 5, 6. If you look at the question, the code below calculates the average of 6 numbers. You understand? So this might be like the first line. Calculate the average of 6 numbers. So read is supposed to like reading the 6 numbers that you want to find their average. So you can see it's saying that SI equals to A, B, C, D, E, F, adding everything together. Now AVG equals to the sum of all of them, the sum of the integers over x. Now print avg. This is, I guess it's going to be taking this as a string, then avg end. Now if you see this avg, now normally if you want to calculate average, your average is going to be the total number of whatever you want to calculate over the count, the head count, like the total head count of those things that you want to calculate. So let me let me do an illustration real quick. If you want to find the average of maybe 3, 7, and maybe say 4. Now normally it will be 3 plus 7 plus 4 over what? 1, 2, 3. The reason why I have 3 over here is because 3 is the number of elements I want to find their average. So normally this is going to be 3.14 over 3. So this should be um 4 point this should be 4.67. This should be 4.67 or so. Yes. So you can see the way I've calculated average here. Just something very simple. Now come back here. So this SI, the answer of this one is going to be 6. The reason is because SI over here is the sum of everything. AVG is SI over the number of elements you want to find the average. So this one is going to be 6. So that is all about number 104. The second one is the next one is number 107. Oh, so okay, so this one is integer remainder. So mod is basically, let me try to explain. I'm sure that I've explained this one before, but let me just explain once more. If I have maybe 10 divided by 3, normally this is going to be giving me 10 divided by 3 is going to be giving me 3.333, like that. So now if I want to say 10, now this one over here is integer division. You understand? Integer division. So let me take it out. So normally this is going to be 3, but 10 mod 3 is going to be giving me 1. Let me explain how 3 and 1 came into existence. If you want to do 10 divided by 3, normally this is going to be 3 remainder 1. Like if you don't want to express it like this, it is going to be 3 remainder 1. But guess what? Integer division is saying that if you do the division the way you would normally, just take the whole number part. So this whole number part now, that is for integer division. But for modular division, the reverse is the case. Modular division is saying that just take this remainder part and go your way. So that is integer and modular division. So come back here. So another name for mod is integer remainder, not integer. In this integer division, it's another operator entirely. So let's continue to the next one. Um, I think the next one is number 110. Okay, yeah, number 110. So dash is a numeric or string value that does not change in the program. That is constant. So for number 110, 2 mod 4. I don't know if I should solve this, but just so 2 mod 4 normally we give you 0 remainder 2. So since it is the remainder part that we are going to be working with, that should be, what's the question again? 2 mod 4. Okay, so 2 mod 4. Now normally 2 divided by 4 is going to be giving you 0 remainder 4. But if you remember vividly what I said about this modular division over here, this modular division is going to be taking the remainder part. So this 2 mod 4, no, it should be 2 remainder 2. Sorry about that. No, 0 remainder 2 rather. So it should be 0 remainder 2. So 2 mod 4 is what? Straight away 2. So um so for 110 the answer is 2A. So for the second one, 9 mod 2 caret 2. Now, if you want to, for the next few questions that we're going to be answering, you guys need to watch this video over here, arithmetic operators in Visual Basic. So these arithmetic operators, I explained the precedence of arithmetic operators here. Let me see if I can get them here. Okay, you can see this precedence over here. So just try to um, get yourself up to speed with this. So 9 mod 2 caret 2. 9 mod 2 caret 2. Now, following the precedence, let me just um, now using the precedence of arithmetic operators, 9 9 mod 2 caret 2. So normally, um, going by the precedence of arithmetic operators, I'm going to be solving this one first, then this one will come second. Anytime you see a question like this, I advise you to first of all number all the operators that you have. It will make your life easier, trust me. Number all the operators you have, then you start solving one after the other. So now that I have numbered my operators, um, actually this one should be 1. Why would this one will be 2? This one should be 1. Why this one will be 2? Because obviously, what do they call it again? Exponentiation comes before modular division. Let me show us. Exponentiation, I think I still have it here. You can see that the exponentiation comes before the mod operator. So please take notes. Please take notes. So let me make this thing monitor. So, okay, so okay. Okay, so I'll be solving this one. This one comes first, while this one is the second one. So now, going with the first one, this will be caret. What is wrong with this thing? Get out. So solving for the caret first. This will be 9 mod. This 2 now is going to be giving me 2 caret 2 is going to be 4. So now the second one I'm going to be solving for is this mod over here. So 9 mod 4. 9 mod 4 is going to be 0 remainder 4. So basically the answer is going to be 4. Let me see the option there. Yes, the answer is C. The answer is C. Yes, 4. So that is all about 111. So for 112 now, you can see this question. Now, one thing is that if you press this directly into your calculator will give you the answer straight away. Let me show us. So on. So let me go back to the computational mode. So this is 4 plus 3 multiplied by 6 divided by 2 minus 5 plus 5 equals to, you can see it's giving me 13 here. Now let's go to solve it by hand. Let's go to solve it by hand. So solving it by hand, I have 4 plus 3 times 6 over 2 minus 5 plus 5. Okay, so let's solve it by hand. Now don't forget, the first thing I said you want to do is to number all the operators. You number all the operators. So if you want to number the operators, normally this will take the first action followed by this. Now the multiplication and the division sign, both of them take the same precedence, but if you encounter something like this, you take the leftmost one, so you solve it from left to right. For example, plus plus, we have the plus at the extreme left and plus at the extreme right. Both of them have the same precedence, but you just handle it from left to right. I think plus and addition and subtraction, they take the same precedence, so you just from left to right. So one, two, then the third one is going to be this one, fourth one, and the fifth one. Yes. So let's start solving them. For the first one, they're going to be having 4 plus 18 over 2 minus 5 plus 5. For the first, after solving this one, because 3 times 6 is what? 18. So I don't have this one anymore. What I have is just 4 plus 18 straight away, then divided by 2. So the second one that I'm going to be working on is the division sign. So for the division sign, I'll be having 4 plus 9 minus 5 plus 5. So the division over here, this is the division over here. So 4 plus 9 minus 5 plus 5. So I have the addition. So the addition, I think, is this one. So 4 plus 9 is what? 13 minus 5 plus 5. If you want to do cancel, I don't know the English to use, so you can just straight away cancel this one since it's just minus 5 plus 5. But guess what? You don't want to do that. So I'm going to be having the minus. So it should be 8 minus, it should be 8 plus 5. Then I have the plus 13. So my final answer is 13, and the option is C. So you can see 13 and the option is C. So for number 113, given the following segment of code, x equals to 0 for I equals to 1 to 5, x equals to x plus I again. So next equals to I. So let me try to break the code down for us. I'm having x equals to 0 for I equals to 1 to 5. Then I'm having x equals to x plus 1 next I. Okay. So what will be the final value of x? That is what they're asking us. So now, let me zoom out a bit. So let's not forget that this one is not part of the work. So now x equals to 0 for I equals to 1 through to 5, x equals to x plus 1. Now, if you want to solve this one sequentially, now initially x equals to 0. When x gets to this line now, it starts when the program gets to this particular line over here. When the program gets to this particular line over here, it starts a loop. Now, starting the loop means that it's going to be looping through from 1 to 5. It is now saying x equals to x plus I. I think it should be I. X plus I. Okay, so for I equals to 1. Okay, x equals to x plus 1. Next equals next I. Now, x equals to x plus 1 for the first iteration. for the first iteration. So for that first iteration now, I will be equal to 1. So x equals to x plus 1, meaning that x will be equals to 0 plus 1. X will now be equals to 1 after the first iteration where I equals to 1. Now for the second iteration now, this I now is going to be equal to 2. So for the second iteration now where I equals to 2, x will be equals to what? X plus 1. What is the initial value of x? 1. Understand? Plus the new value of I, which is 2. So now x will be what? Equal to 3. Now this is for the second iteration. Now for the third iteration, I don't know if this thing is clear enough. For the third iteration now where I will be equal to what? 3. So now x will be equals to what? X equals to 3 plus 3, which is equal to what? 6 for the third iteration where I equals to 3. Now for the fourth iteration where I equals to 4, x will be equals to what? 6, which is the initial value of x, plus I, which is 4, equals to what? 10. So for the fifth iteration where I will be equal to 5, x will be equals to 10 plus 5, which is equal to what? 15. So 15, the option for 15 is C. Now one thing I want you to know is that when you encounter a problem like this one now, like this one, if you know what you are doing, since it is x equals to x plus 1, basically they are only trying to increase the value of x by numbers from 1 to 5, and x is 0. So basically your answer is supposed to be straight away, it's supposed to be 0 plus 1 plus 2 plus 3 plus 4 plus 5, and that settles it. So this is going to be giving you 15 also. It's going to be giving you 15 also. So that is that about that. That is that about that. So let's go to the next one, 15, which is C. So 114. This 114 now, you can see how long it is, but trust me, it's not complicated. So let's start. That will be 2 multiplied by 3 plus 4 divided by 2 is greater than 3. Is greater than 3, and 3 less than 5, or 10 less than 9. Okay, so this is the question over, this is the problem over here. Now to make your life easier, in the arithmetic operators that I referred us to, you can see the bracket over here is the first thing. So let us open this bracket first. That is the first thing we want to do, to open that bracket. So I've written the problem down over here. You can see the way I wrote it down. I don't want everything to be in one line because it will occupy my whole screen. So 2 multiplied by 3 plus 4 divided by 2 greater than 3, and the whole question. So opening this bracket now, opening this bracket, opening that bracket. I think the first one that we are supposed to solve is this one. The second one will be this, and the third one will be this. Now if you open that bracket properly, what you are going to be having for the whole of this one now is 8. So the question translates to 8 greater than 3 and 3 less than 5, or 10 less than 9. The whole of this translates to 8. Now to break this thing further down, From left to right, don't forget. Is 8 greater than 3? True. And is 3 less than 5? True. Or is 10 less than 9? False. Now, I need to refer us to one of the videos I have here. The video is logical operators. Logical operators. Where at that? Yes, logical operators. Actually, I'm going to be needing both relational operators, logical operators, and arithmetic operators to be able to solve this particular one. So, true and true or false. Now, according to the precedence of relational operators, you are going to be having not, then after not you have and, then after and you have or. So this is how it will follow. So if I want to number these operators based on what I have over here now, I'm going to be taking this one first, then this one will come next. So true and true is what? True. Then or false. So finally, true or false, since it is the or operator over here, true or false will give you false. In one of the videos that I referred you guys to, especially that logical operators, you are going to be seeing a truth table there. The truth table will tell you where the reason why true or true, the reason why true and true is true, and the reason why true or false is also true. So just trying to check the video and you'll be fine. Now, I think this will be the second to the last one for this will be the second to the last one. Okay, number 115. Number 115. So number 115. Now, I want us to kind of make this thing a bit more readable. So I'm going to, instead of using true and false, I'm going to be using T and F. Sure you get. I'm going to be using T and F. So to make the thing more readable. Um, so this is T and T or not F or not F and not T and not T or F. I'm trying to occupy the whole screen. Okay. So T and T or not F and not T or F. So T is standing for true and F is standing for false. Now, if you want to number all these things based on what I've said, don't forget this one is not part of it. So let me clean that one out. So let me clean this one out to make it more readable. Okay. Okay. So T and T or not F and not T or F. If I want to number all the if I want to number all of them based on what I wrote here, based on what I wrote here, if I want to number all of them, so not is going to be this not over here is going to be taking the first one. Then the next one is this not over here to be taken to. Don't forget, it's from left to right. So we are moving like this. So 1, 2. Then the third one is going to be this and over here, 3. Then the fourth one is going to be this and over here, 4. Then or will be 5. Then this all over here will be 6. So let's start solving it. So if I want to start with knots, the first knot, the first knot. So it's going to be giving me. Let me increase my pen. So for the first knot, it's going to be giving me true and true, or not false is what? True and not true or false. So that is the first note. The second note now. The second note will be true and true, or true and not true is what? False or false. So I'm going to be, this and over here is what I'm going to be tackling now. True and true is what? True, or true and false or false. So the next one will also be and. So the and is this one over here. True, or true and false is false or false. So the next one is the or. So true or false is true, or false. Then finally, or true or false gives me what? True. So the answer for this one is true, and I think it is B. All right, so we move on to the next one. 116, number 116. We move on to the next one. Another name for comparison operator is relational operator straight away. So comparison operator, relational operator, that's another name for them. So this one signifies not equal to, I think. Not equal to. Not equal to. So the answer for this one is none of the above. I think I've addressed all these ones in the previous video. So um, ah, I'm having some issues here on my end. I hope you won't be hearing strange voices in the recording when it's been uploaded. So let's just continue, please. Um, that is used to repeat a sequence of instructions for a particular number of times until a certain condition is met or satisfied. It's called looping. Looping. So I think we are done with the first set. We move on to the next set and we call it a day. So the second set we go to number six. Number six. Okay, so x plus one is assigned to x. The option is incomplete. That should be the answer. X plus one is assigned to x. Then we go to number 35. Number 35. 35. Where art thou? Yes. So the ASCII equivalent of the word rose is what? Now, if you go to page 61 of that textbook that you bought from computer science department, you will see codes for every character that you can use in VB that's available in VB. So I did some digging on my end here, so I found this picture on the internet. So for all the characters that you have in Visual Basic, we have the decimal representation, the decimal equivalent, the hexadecimal, the octal, and we have the character itself. But please, you need to have some of these things in your head. Like for example, from zero, where is it? Zero now. is beginning at 48, for example. 0 is beginning at 48, like the decimal representation of the digit, not the alphabet. O, the digit 0 is 48. So the next one is 49, which is 151, like that, like that. So if you know the starting point of 0, you can get any of the other ones by just doing a simple count. Sure, you get. So that is 48. Also, the capital A is what? 65. Capital A is 65. So since you know where capital A is beginning, you can trace every other letter by just doing basic addition to 65, which is A. Then small a, as you can see, also is starting at 97. So in case they ask you the ASCII equivalent of a particular character, since you know, you need to know if it's a capital letter, a small letter, or a digit. If it's a digit, now you know that it's between 48 and 57. Just know the starting point, then you can trace the remaining digits. Know the starting point, then you can trace if it's capital letter or small letter. Please take note. Please take note. Now that is one. The second one, for you to get the ASCII equivalent of the word rose, the first thing you want to do is to partition rows into separate characters. This is what I mean. So normally they're asking you to find the ASCII equivalent of the word rose. Don't forget, this is capital letter. Why these three are small letters? Please. Now, you're going to be having R, O, S, and E. And E. Now, we have to go and look for the ASCII equivalent of all of them, of R, O, S, and E. So, what is the ASCII equivalent, the decimal equivalent of capital R? The ASCII equivalent of capital R is what? 82. You can see R here is 82. R is 82. So, since R is 82 now, you come here, R is 82. Now, this 82 now, you convert it to binary. This 82 now, you convert it to binary. So, let's bring up our calculator to do binary conversion. So, mode, don't forget, you put it in base N, then you go to binary. No, I want to convert decimal to binary, so I first of all go to decimal. Don't forget it is 82, so I'll say 82 equals to, you can see, equals to 82. Then to convert to binary, all I have to do is just click on this bin over here, so it will convert it to binary for me. So I'm having 101, I'm having 10 110. I'm having 10 110, so this is 10 110. So keep this one side, the whole of this one, keep it one side. Now for O, let's go and check the ASCII equivalent for O. Don't forget the small letter O that we are talking about here. So O is what? 111. So since O is 111, don't forget it's 111. So come back here, reset everything, go back to decimal. 111 equals to binary equivalent. So I'm having 110 1111. So I'm having 110 1111. So this one too is somewhere. So I'm going to be doing for S and for E down. So come here. So for S, small letter S is 115. Small letter S is 115. So come back here for small letter S, 115. So um, go back to decimal. 115 equal to, then convert to binary. So I'm having 11 1111. 1111. So finally we have for E. Don't forget the small letter E. I think small letter E should be 101. Small letter E should be 101. Um, Small letter E should be 101. Yes, you can see the decimal is 101. So 101. So I'll go back to my decimal. 101 equals to, take me to binary. So I'm having 1100 101. 1100 101. 1100 101. Okay, so I don't need my calculator anymore for now. So now, if you take a good look at this first line now, what we have done is that we partitioned all the letters of rows into separate characters. Now, for this second line now, what we did is that we went to look for the ASCII equivalent of every character. Now, what we did for this particular line is to look for the binary equivalent of whatever is the ASCII code. Now, for us to get the um, the ASCII equivalent of, like, as per the answer to our question now, all we have to do is to concatenate everything together. So the answer is going to be 101001111111100111111. So this is the ASCII representation of rows, and this is the A option. This is the A option. So let's go and see. So the A option is 101. I have two zeros. I have one. I have another zero. I have 11, and like that, like that. So A is correct. That is how you look for the ASCII equivalent of a word. Partition the word, then work your way up from there. So we move on to the next one. Please, like I said, a warning: don't match capital letters with small letters, please. For example, the rows that we were working with now, this is small letter. These are small letters. Okay, I even wrote it down as capital letters. This is supposed to be small letter. This is supposed to be small letter. So please, don't confuse them together. Don't confuse them together. So modem is modulator, demodulator. Okay, we go to number 43 now. Okay, so this is number 43. For this number 43, I'm going to be doing this. This will be the last manual addition I'm going to be doing. So for number 43, okay. So don't forget, this is a typographical error. So, and I assume it is the plus operator that we have here. So normally in your exams, the typographical operators you will see in the course should be minimal or almost zero. I don't know. So binary operations, and let's go to solve that. Now I have 110 1111 base 2 plus 10100 also base 2. So like I told us, this arithmetic operator is not there in the question, but I'm just putting it based on intuition. So 1101111 and 00101. Okay. So I'm adding by hand now, but this will be the last one I'm going to be doing because I want us to close the video. So this will be 1 1, and this will be 0. Bring your 1 here. So 1, another 0. Bring your 1 here. Another 0. Bring your 1 here. Another 0. Bring your 1 here. Another 0. Nothing else. So that will be 1. So this is 1 5 zeros 11. base 2. And there's no answer. No answer. So this is just me talking. So let's see what the calculator has to say. Let's see what the calculator has to say. So this is in binary mode already. This is in binary mode already. So I can just calculate my way. Um, Let me type in this one. So this will be 110 1111 plus 101 000. No. It should be 00. Delete one of the zeros. Okay, equals to. So you can see the answer that the calculator is giving me over here. This is 100 5 zeros then 11. So I don't know. What if we should try using the minus, like instead of adding, let us subtract and see what and see if the answer we get will be in the option, just to be sure. So let us just subtract. So this will be one um 10 11 12 minus 101 00. Okay. So okay. So 110 1111. So this will be 0 0 1 0 and 1. So let me subtract. So this one will be 1 1. This will be 0. This is going to be 1. So this is going to be 10 minus 1 to give 1. This is 0 already, so 0 and 1. So 10 11 0 1 1. 10 11 0 11. Let's see if the answer exists. 10. Okay, that is B. 10 11 0 11 base 2. So I think for this number 43, the arithmetic operator is supposed to be minus over here. It's supposed to be minus. So just take note of that. So for the next one, since I'll just use the calculator straight away. I'll just use the calculator straight away. So this is binary operation and this one is in binary already. So let me just say 110 10 1110. So this is 11 0 10 1110. So plus 10. Please be careful while typing all the ones and zeros. 1111 0 0 1 and 2. So equals, no. I've made a mistake somewhere. I've made a mistake somewhere. 110 10 1110 1110 plus 10 1111 0 0 1 equals to, okay. So I have my answer here, 11 00 100 111. A is the option here. A is the answer here. A is the answer here. For number 44. Oh, I hope I'm seeing correctly. 11 00 100 111. Okay, yeah, that's correct. That's correct. So we move on to the next one for number 45. You don't expect me to do this, but let me just let me just do as if I did it. So go to the decimal mode. 25. multiplied by 23. You can see 575. So guess what? No answer also. You can, this one is even straightforward. 25 times 23. 575. And they didn't give us a base. Or I don't know. They didn't give us a base. So now for binary coded decimal, which is number 46, um, it is almost similar to what you did the other time, but we'll see how I'm going to be doing it. Now, the first thing you're going to be doing, like we did the other time, is to split the digit, the number into its separate digits, 6, 7, 2, 8, and 0. So um, so what you want to do is let me use a table. Let me use a table. Digit, then binary. So digit and binary. So the digits that make up our number over there is 6, 7, 2, 8, then 0, and 0. So 6, 7, 2, 8, 0. Now the next thing you want to do is to find the binary equivalent of all these digits. After finding the binary equivalent, you convert it to a 4-bit binary using zeros to make up for spaces that are not, for digits that are not there. Let me give you an example of what I'm saying. So for this 6, for example, now, where's my calculator? Normally, this should be something if you're familiar with decimal and binary, this is something you're supposed to be able to do on the fly. But let's just use the calculator to make it more. So digit and binary. Go to the binary mode. So 6. No, 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 no. First of all, go to decimal. 6 equals to decimal. So you click on bin for the binary. Now you can see that 6 is 110, 110. 6 is 110, but you have to make it a 4-bit binary digit. So it's going to be 0110. So it's going to be 0110. Now for 7, I think it's supposed to be 0111. Let me go back to decimal. So this one is going to be for 7 equals to the decimal. So now go to binary. You can see it's 111, but it's going to be 0111 instead of 111. It has to be 4 per digit. So 0111. So for 2, I think 2 is 10. So go back to the decimal. 2 equals to, so since you have 2 here now, you look for the binary. You can see 10. So it's going to be 0010. Then for the next one, which is 8, I think 8 is 1000. So you don't need to make up for any zeros. So where at now? Decimal 8. So convert it to binary. You can see it is 1000, 1000 basically. So 0 is going to be 0000 since it's just 0. Now we're almost done actually. Now to convert this to binary coded decimal, you are going to start from up and you are going to be writing everything downwards. You're going to be writing everything downwards. This is what I mean. So the answer that we are looking for is 0110 0111 0010 100000000. When you are done, you write B C D. And after writing your BCD, this translates to the option B. So if you come here, the option B has exactly what we got. Exactly what we got. So you can, it's not very hard, but if you are seeing the question for the first time, it will look very difficult, but trust me. So you can see the digits. You write all your digits out. Then after writing all the digits out, you see the binary. Convert the digits to binary. Then after combining everything to binary, you just concatenate everything together. Just write everything together. At the end, just write BCD, and you are good to go. You are good to go. So normally your answer is going to be in one line though. It's just because I can't. I'm wrapping everything here together. It's supposed to be 0110011001000000000. I'm coming. So you can see this BCD. I think it should be capital letter C, then D. So everything is supposed to be in one line. That's what I'm trying to say. It should be in one line like this. Huh. So that will be the answer. So moving on to the next. Okay, let's move on to the next one. We are going to number 47. We move on to number 47. The binary equivalent of this. Now, this one, your calculator will not be able to do it for you, so you have to do it by hand. You have to do it by hand. Now, how will you be able to solve a question like this one? The binary equivalent of a floating point number. So don't forget, this number over here is in base 10. So let's move on to solving it. Um, mm, okay, let me use this one. So 0.8125. Don't forget it's base 10. So, but we don't have to put that one. Now, what you want to do normally is to say 0.8125. You multiply by 2. It is in binary. I want to convert it to base 10. This is going to be giving you 1.625. Then this one you leave it. This decimal part over here, you say 0.625 times 2 is going to be giving you 1.25. Now this 1.25 again, leave the 1. This 25, 0.25 multiplied by 2 is going to be giving you 0.5. This whole part, leave it alone. This decimal part, bring it out again. 0.5 times 2 is going to be giving you 1. Now, if you notice very well, if I should start multiplying 1 by 2, anything that it gives me by 2, by 2, by 2 again, normally this is 1.00. So I cannot say 0.0 times 2. It's still going to be giving me 0. You understand? So there's no point. So we can just halt it from. So we can just stop it here now. So basically, our answer now is going to be this. It's going to be that. So the answer to the question at hand is going to be 0.1101 base 2. And this is the option E. This is the option E. So you can see the way we convert binary you look for the binary equivalent of a floating point decimal number. One thing you should know is that this 0 over here now, if it were like 60 or something, you solve this one for the binary equivalent, you solve this one for the binary equivalent too. So that way you will know how to combine everything together at the end. But for now, they did not send us this one. This is what they sent us. This is what they sent us. So we have done our own part. So your calculator will not be able to do this one for you. So because like I said, your calculator works only in integer mode. The base n works only in integer mode. So let's try to do it. Decimal 0 point. You can see the point is not working. The point is not working here. Or I don't know, perhaps if there's any other way to do it. But this is just me speaking for myself. So come back here. The next question to solve is 48. So you look for the decimal equivalent of this number over here, 0.101 base 2. So let me come back here. So the decimal equivalent is going to be, let me just 0.101 base 2. Okay, so normally what you want to do, oh no, I don't like the way this thing is close to the top. 0.101 base 2. So normally the way we do normal decimal binary to decimal conversion, you have 0 here, -1, -2, and -3. So moving on, you're going to be having 0 times 2 raised to power 0 plus 1 times 2 raised to power -1 plus 0 times 2 raised to power -2 plus 1 times 2 raised to power -3. So now the whole of this is going to be giving me 0 because 0 times any number is 0. So 0 plus 1 times, this is 1 over 2. So basically this should be 0.5, but let's not skip any step. Plus this 0 times, this one will give me 0. Plus 1 times, it should be 1 over 8. So this is going to be giving me 0.5 plus 0.125, and guess what, the final answer will be 0.625 everything base 10. But you don't have to put this one, you don't have to put this one, but just for official purposes. For official purposes. So that is that about that. Okay, and this is going to be the C option. So this is going to be the C option. The C option. And the C option you can see is 0.025. So we move on to number 77. Okay, the product of these binary numbers. The primary school way of doing it will work, but I'll just advise you to do it with your calculator. So take it to binary, then 1011 multiplied by 111 equals to what? 11101. That is D. Okay, actually B and D are correct because you can see, okay, because of this dot over here, I don't want to trust B anymore, so I'll just go with D. 11101. Both of them are correct actually. You can see 11101. So we move on to number 152. Please, I'm sorry for the all the strange sound you might be hearing in the background. Yeah. So 152. We move on to 152. Okay, this is 152 here. So the BCD of 864. The BCD of, was it 864 we did the other time? No. Okay, so let's just quickly do the BCD. The BCD of 864. Um, what is wrong with this thing? Okay, the BCD of 864. Come in place. I need to set some things straight here. Um, I need to set it straight. I don't like the way it's big. Okay, let me use this. Okay. Okay. So the BCD of 864, right? 864. So this shouldn't take us time at all. Don't forget, we first of all split the numbers. Oh no 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 no. 8, 6, then 4. So I have to convert everything to a 4 bit binary. So this one will be 1000. If you use your calculator, I don't want to waste too much time, but decimal it equals to then the binary. You can see 1000. But for 6, if I go to decimal, then 6 equal to, then go to binary 110, so it will be 0110. Then for the fourth one, no, for 4, let me bring my calculator somewhere here. So for 4, don't forget to go to decimal first. 4 equals to, then you come back to binary. You can see 100, so it will be 0100. So I think our answer has showed up. Basically, our answer is going to be 100001100100 B C D. So I think this is the option D. This is the D option. I think this is the D option. So 100001100100. Yes, BCD. It's supposed to be at the end, but they didn't add it, so it doesn't hurt anyway. So 153. Okay, the answer of this one is 0 to 7. The symbols of the octal system. So what's the next number? 163. Sorry, please. So 163. The ones complement of 010. Okay, to achieve this, I think I can't remember the page where it is in the book, but there's a way you can do binary subtraction using the ones complement method. So normally the ones complements, like I showed us in one I solved earlier, I said you just flip all the zeros and the ones together. But in this case now, since you are subtracting from 4 digits, you turn it to a 4 bit binary. So this should be 100, but it will have a 0 at the back, so it will be 0100. So 163, sorry, in my honest opinion, is A. So if you have any contrary opinions, please, the comment section is open. You can always drop it there. So For 164, I don't know, but there's a bit of confusion here because I was this is we have 4 digits over here and we have 4 digits here to flip. Now, the ones complement of this is supposed to be 0101, but I have 01011. I want to believe this one is a typo. I don't know, but for me, the way this stands now, there is no answer here unless this is supposed to be a typo. I don't know. So, but in my honest opinion, like I would say, this should be 0101. Like the comment section is open, please. You can always drop your opinion there. So I would like to learn from you too. I would like to learn from you too. So let's move on. We move on to number 190. We move on to number 190. 190. Okay. I hope I'm not skipping any important number here. Okay, the BCD of 864. We've solved this before. So the product of these binary numbers, this and this, you can do it the primary school style, and it works too. Trust me. Let's do it. Number 189, the primary school style. I didn't write the question down. So this will be 1011 times 111. Okay. So 1011 times 111. So this is be 1011 then 111. Okay. So I'm having 1101, 1101, then I have 110, then another one. So putting all this together, so this is going to be 10. Put one here, I have one. Put one here, I have another one. Put one here, I have 0. Put one here, I have 0, then I have my 1. So this is 100, 110, 1. So let's see what the calculator has to say. Let's see what the calculator has to say. I hope I didn't make any mistakes. 1011 times 111. 100, 1101. Yes, correct. So, like I said, the primary school style, it works as well. So, whichever way you want to do it. 100, 1101. Yes. So, the decimal equivalent of this, your calculator will not be able to do this. So, let's let's get to do it. 101.01 base 2. Okay, so like we would normally, this will be 0 minus 1 then minus 2, then 0 1 2 then 3 at top here. So one thing is that to save us time, this 0 and this 0, it will amount to 0, so let's just skip those ones. So this will be 1 times 2 raised to power 3 plus 1 times 2 raised to power 0. So I'm not using this ones. So plus 1 times 2 raised to power minus 2. So you can see I'm using this one, and this one as well. So this should be 1 times 2 raised to power 3 is 8 plus 1 times 1 is 1 plus this is 1 over 4, right? So this will be 9 plus, should be 9 plus 0.25. So this will be 9.25. So in my own honest opinion, once more, there is no answer here. But in your exam, there is answer there, because those options they'll be checked thoroughly. So I don't have 9.25 anywhere here. I want to believe there's a typographical error somewhere, but I don't know. So to convert 45 to binary, octal, and hexadecimal, let's just run this through with the calculator. Um, so you go to decimal, 45 equals to, so when you are done, you say, for the binary, you write binary. So 101101, 101101. Okay, A and D are still in the race. Then we have octal. For the octal, it's 55. So then the hexadecimal, this one is out of the race. So if the hexadecimal is 20, then you can see for 45, the hexadecimal is 2D, not 20. It's 2D, not 20. So 121, I don't know. Wait, decimal again. I typed 45, and in hexadecimal it is 2D. So obviously this question has no answer. But the closest one to the answer will be A, because as you can see, it's 20. No, the person that typed this might want to type 2D. So 191. Let's solve it by hand first. I'm not saying the calculator is wrong, but I think it's 45. And we are trying to change to base 16. So normally 16, 45. So the closest one is 32. It's 32. So 32 minus 45. 32 minus 45. So this is going to be 3, 1. And this is the representation of D, because I know that A is 10, B is 11, C is 12, then D is 13. So get out. So this is D. Then if I bring in 16 again, this is going to be remaining. What am I doing? No, no, no. This should be 2 remaining D. 2 remaining D. Then 16 again. It will be 0 remaining 2. And don't forget. So the answer to this one is going to be 2D and not 20. It's not equals to 20. So this is the answer. This one is wrong. This one is wrong. So this number 191, like I used to say, in my honest opinion, has no answer, but A is the closest one. So you can just go with that one for now. But please, in your exam, it has answer. Those options are going to be typed like the answer is going to be there. That's what I'm trying to say. So number 194. For number 194, okay, we have a bit of analysis to do here. For number 194, in box A, what happens can be described as. Let me just say what is happening in all the boxes. So, because you can see that the boxes are not labeled, so we don't know which one is A, B, or C. But this one over here is called the program start. So you can just call it the initialization. You understand? Program initialization, then program termination. This top over here is program termination. So this is decision making. What is happening here is decision making. This is input, this is output, while this is processing. This is processing over here. So depending on how they label the boxes in the exam. So now it is saying how many times will the loop terminate? With the loop, normally it's saying terminate here, but it is wrong. It should be how many times will the loop iterate? That should be the correct thing to do there. How many times will the loop iterate? So let's go ahead to analyze the program. To analyze the program. So I didn't write the program out. So I'm saying x equals to 12, sum equals to 0, and y equals to 2, and y equals to 2, and y equals to 2. So x will be equals to x minus 3, sum equals to sum plus x. So y greater than x. If no, go back here. If yes, then we'll do whatever you want to do. Actually, this one is not very important. So you can see the way I picture the question now. So I'm saying x equals to 12, sum equals to 0, and y equals to 2. So this x over here, x equals to x minus 3, then sum equals to sum plus x. I have told us that this statement, you are increasing sum by the value of x, basically. That's what you are doing here. You are increasing sum by the value of x. So x equals to x minus 3. What do you want to do here? Normally, what you want to do is to check. This x is 12 initially. Now, why the program is coming to execute for the first time, x will be 12. Now, you have reduced x by 3, which is 9. Which is 9. Now, sum equals to sum plus x. So, no iteration have occurred. What is sum? Sum is 0. But you have increased 0 by the value of x, which is 9. So, I think we need to draw a table here. So this will be the iteration, the value of x, then sum. Then sum. So now at iteration 0, no iteration have occurred. The value of x will be what? 12. No, not 12 actually, because at iteration 0, this is x over here. Then x equals to x minus 3. So that will be 12 minus 3, which is 9. Sum is going to be 9. You understand? Because sum is initially 0. So before the first iteration, sum is 9 and x is 9. Now, we iterate for the first time because y is not greater than x. What is y? Y is 2 and x is 9. So this condition doesn't hold. So it will go back to do what? To check. To do all these ones over here. So x equals to x minus 3. X is 9, don't forget. Minus 3 now, x is going to be 6. Now, sum is going to be sum plus x. Sum is initially 9. But I'm going to be adding 6 now, making 15. After the first iteration. So I hope this thing will not be too tiny on your device. So now, going to the second iteration, because this is 6 over here, and y is not greater than x. Y is 2. X is 6. So nothing can happen for now. So for the second iteration, we'll come in please. For the second iteration, okay, x equals to x minus 3. So that will be 6 minus 3, which is 3. Then sum is going to be sum plus x. Sum is initially 15. What is x? X is 3. 3 plus 15, that will be 18. That will be 18. Now, this is 3 over here, and y is 2. Y is not greater than 2. So another iteration will occur. So I have this other iteration over here, the third iteration that has to occur. Now, for this third iteration now, x is 3. X is 3 and x is 3. Now x equals to x minus 3. So this will be 0 and x equals to x sum plus x. So this one will still be 18. Now, y greater than x, y is 2 and x is 0. So it will not go back here, but rather it will go and like continue the program. If you take a good look at the diagram that we have over here now, y greater than x, it is just going to print sum and stop. So I think we've been able to solve the next 2 or 3 questions now. You can see that the number of iterations, the maximum number of iterations that we have is 3, and the final value of x is 0. The final value of sum is 18. So this will be iteration x and sum. So let's go and check. How many times will the loop iterate? Normally, I would say 3 because obviously you can see the calculation we did. The iteration was 3 times. The final value of x is 0. The final value of x is 0. So the number 197 is A. So in the program, the number of loops that we had is 3. Is 3. Wait, how many times will the loop terminate? I don't understand what this question is saying. Normally, it is once that is supposed to terminate. So this one is supposed to be 1. I don't know if there's any other. I don't know what this question is talking about, Sha, but I'm sure it's a typographic error or something. So um, in the program, the number of loops 3. So that is just it. Now for 200, the command in line 20 terminating, they didn't give us the code here, so there's no point. Now the equivalent of the number this in the octal system. You see this number over here in the octal system. So guess what? Maybe I should speak Yoruba so you'll understand that I'm serious. You cannot go to, you see that exam hall, eh? That exam hall, you cannot go there without a calculator. Trust me. You do not want to go. They might intentionally put questions there that will waste your time. Trust me. So if you are doing it by hand, see this kind of question that we are talking about now. So it is in binary. You have to convert to octal system. The way I know you can solve this kind of question is to first of all convert the binary to decimal, then from decimal to octal. You understand? In this case now, with your calculator, you can just juggle everything in less than a minute. So please, don't go to that exam hall without a calculator, please. But if you cannot afford one, it is not the end of the world. You can still go and make your A, to be honest. So let's come back here. Where's my calculator? So come back here. This is a binary value. So go to binary. 100111 0111 011. Okay, so equals to, then in the octal system, oct 11673. A is the answer. I will move. So that is number 203 solved. Then we move on to the next one, which is 208. Okay, this is 208. So for this number 208, the decimal equivalent of this in base 2. Let's solve it. Let's solve it. Let's solve it. So that would be 10111.011 base 2. Base 2. Okay, so to solve this, what you do normally: 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. So you start. So this will be 1 times 2 raised to power 4 plus 1 times 2 raised to power 2 plus 1 times 2 raised to power 1 times 1. No, 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 this should be plus 1 times 2 raised to power 0 plus 1 times 2 raised to power minus 2 plus 1 times 2 raised to power minus 3. Okay, so the next thing you want to do is to start bringing everything down. I have 16 plus 4 plus 2 plus 1 plus 1 over 4 plus 1 over 8. How do I arrive at all these things I'm writing? So the whole of this one now is this 16 over here. The whole of this one is this 4. The whole of this one will give me 2. This will give me 1. This will give me 1 over 4. And this will give me 1 over 8. So we are moving on. So this will be 23. No, 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 no. That's too long. 23 plus 0.25 plus 0.125. This is going to be giving me 23.375. And this translates to the A option. This is the A option. So we continue. 209. So for 209, solving this by hand will not take your time, but I'll just use the calculator. So this is a hexadecimal addition. So come to hex, b4 plus 5c equals to, as you can see, 110. That is A. 209 is A. So we move on to the next one. I think the next one is 270. Next one is 270. Okay. So, okay, which of the following is an integer data type? So 30 is the integer data type here. Because 6.5 is a decimal. This is also a decimal. Um, x minus 1 is an expression. So it's an expression. So b is the only integer data type here. From there we move on to 301. 301. 301. What value will be stored in this? So normally, just press it into your calculator and go your way. Just press it. Okay. For questions like this, I think it's better we solve by hand because it is not in these questions, but a typical question that they might ask you in the exam. In the exam is they will give you a particular question like an equation like that: 2 multiplied by so 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 times so so so, integer division, something do something, another thing do another thing, like that. Now that kind of question, they will tell you that which of the operators are you going to be solving. We take the sixth action, like they might tell you that which of the operators will you solve first, or the second operator you will solve, or the third operator to solve. So if you know how to number your operators like that, it will be easier for you to juggle around those kind of questions. So these particular kind of questions, we are going to be solving them by hand. So let's continue what we are doing. For this particular question, In the exam, please, you press it to your calculator and you go your way if they are not asking you the operator to solve at any point. No, no, this is not what I'm looking for. Okay. So the question is 2 5 minus 8 2 plus 2. Okay. So let me increase the size of my pen. So if I want to number my operators like that, this is 1, then this is going to be 2, and this is going to be 3. So this is going to be 3. So solving it now, the first operator, the 8 divided by 4 is going to be 8 divided by 2 is going to be 4. So you'll be having 25 minus 4 plus 2. So this second one over here, 25 minus 4, is going to be giving me minus 21 plus 2. Then the final one will be 23. And this translates to the C option. So we move. So number 302. Oh, get out. Okay, number 302. Which of the following name is written correctly? It's written incorrectly. So C3 is correct. Root 1 is correct. X mass is correct. So X dot 7 is wrong. Customer name is correct because of the dot over here. That dot makes X dot 7 wrong. So after 302, we are going to 306. Okay, number 305. Which of the following numeric constants is written correctly? I'll go with A. I'll go with A. I'll go with A. 3000. So um, I don't know if VB will permit you to do this. I don't know. I know it's permitted in some programming languages, but I've never had to. Wait. Let's quickly look for it. Scientific representation. In Visual Basic. So let me see if there's anything like that. Okay, this works actually. Okay. So this is wrong, and I don't know, for one funny reason I'll just go with A. I'll go with A. It is not specifying if it's a decimal or a whole number, so I'll just go with A here. I'll just go with A. So for 306, the computer will not understand this. The computer will not understand this. Let me do some illustration. 2 into x plus 3y. 2 into x plus 3y. Yes. Two into x plus 3y. Now, if you want to do something like this in the computer, you cannot give the computer this. It will not collect it from you. But what you can do is that since this one is in a bracket now, you can just sort this bracket out first. So sorting the bracket out, we are going to be having x plus 3. Now you have to put a multiplication sign here. Why? Sorry. The computer doesn't understand this. But since what you intend is for 3 to multiply y, you can do something like this. Now, in this particular use case, going by precedence of arithmetic operators, if you leave this thing like this, the way it is, it will still give you the same meaning as what is here. But I don't know, for some program you might want to write, it may not give you the same meaning. One might come before the other one. So the safest thing to do is for you to put this in a bracket. So you know that no matter what happens, this is going to be executing before any other thing. So this is in a bracket, so just close this. Then you say 2 multiplied by anything that is here. So I think that is it for this particular number. So 2 multiplied by x. Okay, I think this is what they did. This is what they did. So for now, we just go with C. We go with C. So 307. What is the result of the function len address on the given expression? Now, address is a variable, and the value of address is faculty of science. So all you have to do to get the answer to this one now is to count all the characters that make up faculty of science, including the spaces. Including the spaces. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, then 18. So if you remove the spaces now, you're going to be getting 16, which is also in the option. You might be tempted to choose 16, but hey, you're your own. Oh. The answer here is 18. So what is the result of the function L case? This L case stands for lowercase on address faculty of science. So basically, to just convert everything to lowercase. So here your answer will be D, faculty of science. So which of the following is a valid VB integer? This is the valid integer here. This is the valid integer here. This is 5.8. This is all these commas here. No, we don't want. So the next thing we want to go to 311. Okay. So 7.7 backward slash 1.7 in VB. Don't forget, this is integer division. Integer division. And integer division is telling you that you only take the whole number and do away with the decimal. So I think let's just use our calculator. Let's use our calculator. Where are you? So mode 1, 7.7 divided by 1.7 is going to be giving me, you can see, 4 point something. Now what I need is just this whole number 4. I don't need this extra whatever. So my answer here is going to be 4 because that's the whole number. So that is just it. So the arithmetic operation expression x caret n is x raised to the power of n, basically. So I don't know, it's raised to the power of none of the above. The equivalent is none of the above. So which of the following assignment statement is wrong? This is correct, this is correct, this is correct, and this is also correct, but this is wrong because of the colon here, because of that colon. So what is the result of the following operation? Int minus 2.3. I think it's going to be giving you minus 3. This. But let's go and do the experiment. Int minus 2.3. You see? Minus 3. So this one is going to be giving us negative 4. You can try it on your end. So the following operations can be carried out on strings, except don't forget strings are collection of characters. If you want to know more about strings, actually it will do you a lot of good if you can go through all these videos. It will do you a lot of good if you can go through all these videos. I don't know where I spoke about strings. I think variables, data types, and console input and output. These three, I think you should get a grasp of what a string is. So string basically is a collection of characters, like a collection of characters. Characters can be numbers, it can be alphabet, it can be alphanumeric, So just like that. So the following operations can be carried out on a string except lowercase can be carried out on a string, length can be carried out on a string. This left and MID, I don't know what they are exactly, but one I'm sure of is ABS. So D, this is the answer. This is the answer. ABS. Absolute value. It can only be carried out on numbers and not alphabets. So number 317, the answer is D, 255. And number 318, the answer is also D, infinite. So the maximum permissible length of a variable name is 255 square. Like 255, that is the value. So for 318, the maximum permissible length of a string constant can take um any length. So I don't know, 319. Okay, the answer to this is triple. The answer to this is triple. 320. The answer to 320 is when. So 321 is U case because that U case is used for to convert strings to uppercase. So there's nothing like capital one, small one. So it's just uppercase and uppercase. You can't perform that kind of operation on strings, on integers rather, on numeric variables. So we continue. 322. The following arithmetic operators are available in VB except C. I don't know what B is actually. So I think there's a typo here. I don't know what B is. 323. The answer is dim. The answer is dim. I think I've attended to all these questions in the previous video, so let me just skip some of them. So the following for next loop makes how many passes? Don't forget what I told us about the explanation I did initially. So this one is from 1 to 10. So obviously it is counting from 1 to 10 and making it to have 10 passes, just like that. So if it were from 0 to 10, you know that it will be counting 0, 1, 2, 3, and it also counts for 10 too. So that would be 11. But in this case, the answer is 10. So I've answered all these ones. I've answered all these ones. Okay, for 339, given that the numeric variable n equals to 4 and string variable answ equals to y, which of the following condition is false? Which of the following condition is false? So let me write it out. Actually, there's no way for me to juggle everything together in one place. So let me just use it here. So which of the following condition is false? It's saying that 2 is less than n and n is less than 6. N is 4, so this is true. Not n less than 6. Now what is n? N is 4. Is 4 less than 6? Is true. So not true, it's false. So obviously B is already an answer. So for the third one, let's say C. 2 is less than 4, yes. Or n equals to 6. N is 4. So 4 is not equals to 6. So this is false and this is true. But since it is or here, if you check these logical operators that we have here, you will know that true or false is true. True and false is false. So just get that. Not ANSW equals to Y. Not ANSW equals to Y. You can see that the value that they hold, this is Y over here. This is capital Y, this is small y. So ANSW equals to Y is going to be yielding false. Not false is what? True. So n equals to 2 and n equals to 7. Obviously n is false, so both of them are already false, so this is false. Or ANSW equals to capital Y, so this is true, but this is false. False or true according to the logical operators is true, so B is the only one that is not true there. So for 1 is less than or equals to 1 is true, 1 is less than 1 is false. 1 is less than 1 is false, so that should be the answer. um, Given that the numeric variables a and b are 4 and 3 respectively, and the string values c and d are hello and bye respectively, which of the following condition is false? A plus b is less than 2 multiplied by a. I think a is false because a plus b, 4 plus 3 is 7, and 2 multiplied by a is 8 actually, so 7 is less than 8 is true actually. So b is what? 3. Okay. C is hello. Length of hello is 5. 5 minus 3 is 2. What is a? A is 4. 4 over 2 is 2, so 2 equals to 2, so this is correct. So b less than a. If b is 3 and a is 4, b is obviously less than a. Now c is less than good ampersand d. Okay, I think this is and. What is d? By. In programming, there is this funny, I don't know what to call it, but it actually comes in handy. If you look for the boolean value of a number that is not zero, you are going to be getting true. The boolean value of an empty string or zero or an empty array or 0.00, anything is the boolean value is false. So the boolean value, I think the boolean value is what they are expecting us to use here. So good and good, since both of them are not empty strings, obviously it will be true. And c is not 0, which is an empty value, it's also true. So I don't know, I might want to choose none of the above here, but like I said, the comment is open if you have any contrary opinion. So for this last one that we have over here now, it's a very interesting question, and oh god, thank god I'm a mathematician. Maths is sweet till I got to Unilag, obviously. So Unilag maths too is sweet, you say the truth and shame the devil, but I cannot tell you the rest. So given a loop that will generate every fifth integer beginning with I equals to 1, so and continue for all integers that are less than 150. 346, how many integers will be generated? 347, what would be the value of the sixth integer generated? 348, what will be the sum of the integers that are evenly divisible by 6? Then 349, what will be the sum of those integers that are not evenly divisible by 6? And what will be the value of k that will cause this loop to terminate? Now, if you take a critical look at this problem that we have over here, it's an AP problem, arithmetic progression. With arithmetic progression that you did in secondary school, you will solve this problem correctly. Now, let us get to it. Let us get to it. Now, using AP to solve, I will be equals to what? 1. Now, the common difference will be equals to 5, because if you look at the question, it is saying that it is in fives, the next 5 digits. Now, it is to tell you that the first term of the AP, which is A1, is equal to what? 1. Now, common sense will tell us, will tell us that since it is the next 5 numbers that is going to be generating, and the number must be less than 150. Now, close door now. And the number is going to be less than 150. So the last number to be generated is going to be 146. Sure you get. Now, since it's going to be 146, and it's an AP problem that we are trying to solve here, the total number of integers is going to be n. So let's say n equals to the total number of integers generated. Now, the formula for AP, a plus n minus 1 into d equals to an equals to an. So a equals to 1, d equals to 5, the an will be 146, and n will be equals to what we don't know, the mystery number. Now, since an no, I'm making a mistake somewhere. Okay, so equals to an. So now, since n is what we are looking for, we have our a, we have our d, we have the an. So we have to look for a way to make n the subject of the formula. Then we plug in our values into n. Then we move our way up from there. Now, I want to save time, so just make a the subject of the formula on your own end. You are supposed to be getting n equals to an minus a, everything divided by d. So this is going to be 146 minus 1 over 5. And this is going to be what? N will be equals to 29. And that will be the answer. No. Yes, 29. And this is going to be option B. So if you come back here, 29, you can see B. Now, what will be the value of the sixth integer generated? This one is a straightforward problem. So, what will be the value of the sixth integer generated? So, don't forget, a6 will be equals to a1 or a0 plus n minus 1 into d. So, what will my a6 be? My a6 will be 1 plus 6 plus 1, 5, which is equal to 1 plus 5, this will be 5.5, which is 1 plus 25, which is 26. So now that 16 integer, now if we want to calculate it manually, if you want to get to that 16 integer manually, normally you are going to be starting from 1. If you add 5 to 1, that will be 6. Another 5 will be what? 11. Another 5 is 16. Another 5 is 21. It's 21. Then another 5 is 26. So I don't know, am I making a mistake here? So how many integers will be generated? So given a loop that will generate every fifth integer beginning with I equals to 1. Beginning with I equals to 1. Beginning with I equals 1. I think there's a mistake somewhere here, because If I equals to 1, then it means the first integer to be generated will be 6. So we need to come back here to our drawing board and do some adjustments. A is supposed to be 6 and not 1. A is supposed to be 6. So if this is 6, this is supposed to be 30. This is supposed to be 30. This is supposed to be 30. So A will be C. A will be C. So the next one, the sixth integer to be generated is going to be 31 or so. So 31. Because this is the first one that will be generated. I equals to 1. I equals to 1. So the first to be generated will be 6. So these are the adjustments I've made here. So my A is 6. My A is 6. Then the reason is because if you take a good look at the question, it is saying that I equals to 1, meaning that the program is giving us the count variable as the initial value of 1. So the first value to be generated will be 6 and not 1, because 1 was given by default. So the one that will be generated will be the first one to be generated will be 6. So if you make your A 6 here, so A is supposed to be 6. Please take notes. Please take notes. So 146 minus 6 over 5, that should be 140. 140 over 5. N is supposed to be 28 rather. N is supposed to be equals to 28. N is supposed to be 28. So for this next one, so this is going to be 6, 6, 6. So 6 plus 25, that will be 31. And if you look at, if you see what we are doing here manually, you will see that this is the first one to be generated, the second, the third, the fourth, the fifth, and the sixth one. So that settles it. That settles it. Sorry for the error from my end. So we move on to the next one. We are almost done actually. So what will be the sum of those integers that are evenly divisible by 6? Those integers that are evenly divisible by 6. Don't forget, all the numbers that we are going to be generating, 1, 6, 11, 16, 21, 26, 31, and a count like that till we make sure that it doesn't go above 150. So for you to solve this number 349, no, 348, numbers that are evenly divisible by 6, evenly divisible by 6, evenly divisible by 6, you're going to be having 6 plus 36 plus 66 plus 96 plus 126. All you have to do to get all these numbers is to just keep generating all these values over here. The next one will be 36, 41, then 46, 51, and so on. So just keep generating the numbers. You will get all these ones over here. You will get it. So the sum of all these ones, the sum is 330. And that is the C option. That's the C option. So integers that are not divisible by 6. Integers that are not divisible by 6. So every other one apart from this one. So basically, what you're going to be doing is they're going to be saying 11 plus 16 plus 21 plus 26 plus 37 plus 41 plus 46 plus 51 plus 56 plus 61 plus 71 plus 76. So you keep generating all the numbers till you get to 146. Make sure that any number that you add there, it is not divisible by 6. Or let me just complete it. Let me complete it. 76 plus 81 plus 86 plus 91 plus 96 plus 101 plus 106. No, 96 is not going to be there. 96 is not going to be there. Anyone that's divisible by 6 is not going to be there. 106 plus 111 plus 116 plus 112 plus 131 plus 136 plus 141 plus 146. So if you add everything together, it should give you 1875, and this is the D option. This is the D option. So just sit down and do the calculation. I don't know if I've omitted anyone or I've just sit down and do the calculation on your end. This thing is not difficult, trust me, but I'm sure this is the answer. So going to the last one now. What will be the value of k that will cause the loop to terminate? Now the value of k that will cause the loop to terminate, if you take a good look at it, I don't think it should be k, it should be I, because if you check all these ones that we have been dealing with I, so I don't know where k is coming from, but the value of k that will make the loop to terminate is 151. The reason is because the last integer to be generated, since it has to be less than 150, is 146. Now the next integer after 146 that will be generated is 151, and obviously it will make the loop to terminate. Sure you get. So 151 will be the answer for the last one. So well, um it has been a very long recording. It has been a very long recording. So I wish you guys success in your exams. I wish you success in your exams. So if you have any questions, you can always drop it in the comment section. I will attend to it, and if I have to do another video for you guys before the exam to explain one or two things, I won't mind doing it. So just drop your questions in the comment section and I'll attend to it. So thank you very much, and don't forget to subscribe to the channel and hit the notification bell as well, and try to share this video with someone else so those people can benefit from it as well. So thank you very much. See you any other time I see you. Bye for now.